Here we'll learn to graphically represent motion. What do you mean by graphically represent motion? Look at the graph number 1. This is graph number 1. What does it tell us? Here is a body. It records the speed, the time and displacement of the object. So at 1 second, the displacement is 5 meters. At 2 seconds, the displacement is 10 meters. At 3 seconds, the displacement is 15 meters. At 4 seconds, the displacement is around 20 meters. At 5 seconds, the displacement is 25 meters, which means as the time is increasing, the displacement of the object is also increasing. And if you observe very carefully, for every 1 second, there is a displacement of 5 meters. For the next 1 second, the body moves another 5 meters. So this body now is moving equal distance in equal time. For every 1 second, it is moving 5 meters. Because let me go over that part again. See, for the first second, it is at 5 meters. At the second second, it is at 10 meters. Third second, it is 15 meters. Fourth second, it is at 20 meters. So have you seen, for every second, between the first and the second second, it has moved 5 meters. Now look for the second and the third second. It has moved from 10 meters to 15 meters. It has moved 5 meters. Now between the third and the fourth second, it has moved from 15 meters to 20 meters. So it has again moved 5 meters. Means for equal time, it covers equal distance. And yesterday we learned such motion is called uniform motion. And the object is moving with a constant speed. Let's get on to the next graph. Now this is the second graph, and in this graph see, at 1 second the object is at 15 meters. At 1 second the object is at 15 meters. At second 2 second, it is also at 15 meters. At the third second, it is also at 15 meters. What can you say about this object? At fourth second, 15 meters. At fifth second, also 15 meters. Sixth second, also 15 meters. The object is not moving. It is at the same distance. So this is the graph of an object which is at rest. So here the object is not moving because the distance is remaining the same. It is at the same distance. So it's a body at rest. This is a graph of body at rest. Let's examine the next graph. Now here again, at 1 second, the object at 1 second time, the object is at a distance, say 2 meters. At object at 2 seconds here, it is at 5 meters. At 3, let's take 3. At 3, it is at say 7.5. At 3 seconds, 7.5. At 4 seconds, it is somewhere at 12.5, and it goes on. Here if you calculate, you will find as the time increases, the object is covering more and more distance. So in this unequal, it is covering unequal distance in equal intervals of time. This is a non-uniform motion. The speed is not constant. See, for the first 1 second it has covered 3 meters. Then it has covered 2.5 meters. Then it has covered 5 meters. And as you go higher and higher, you will find for every second it covers more and more distance. So it is covering unequal distances in equal intervals of time. And such motion is said to be non-uniform motion. So if the graphs were just given to you straight on like this, for this graph you would say the body is in uniform speed. It's a moving body with uniform speed because it is a straight line. So this is uniform speed. Or in other words, it is uniform motion. Look at this next one. Here the object, it is parallel to the axis. This is your axis. This is your time axis, the x-axis, and it is parallel. That means the body is at the same point. The distance is the same. So this is a body at rest. If you look up here, this body now, here see, it's going faster and faster. This is non-uniform motion. It moves faster and faster. It's not a straight line, it is a curve. We'll now look into the velocity time graphs of certain bodies. Look at the first one. Here the object, the velocity time graph is just a straight line. At 1 second, the velocity is 10 meters. So we said at 1 second, the velocity was 10 meter per second. At the second second, it's also 10 meters. At the third second, it's also 10 meters. At the fourth second, it's also 10 meters. So second, it is also 10 meters. Then this also is 10 meters. This is also 10 meters. So the body is moving with a constant velocity. The velocity is not changing. And such motion with constant velocity is called uniform motion. Where the velocity does not change, it is called uniform motion. And here we can say the acceleration is 0 because there is no change in velocity. No change in velocity means the acceleration is 0. So the first graph is the graph of uniform velocity. Now we'll go on to the second graph. Now in the second graph, see, I'll just mark this as maybe this is 5. Here we have 10. $25. Here for the first second, the speed is 5 meters per second. For the second, it is 10. For the second, it is 10 meters per second. Now let's see for the third second what happens. It is somewhere here. So for the third second, it is 15 meters per second. And you would realize here by now that for every second, the speed is increasing by 5 meters per second. Here also from the second to the third second, it was first 10 meter, now it has become 15 meter. There is an increase of 5 meters per second. So in this graph, in our second graph, the velocity is increasing, but by equal amounts in equal intervals of time. And such a motion we learned yesterday was called uniform acceleration. So here we will write uniform acceleration. Why uniform acceleration? It increases the velocity increases by equal amounts in equal interval of time. Such a motion is called uniform acceleration. Now in the third one here the velocity is decreasing. Have you seen? It is coming down. The velocity is decreasing. At the 0 seconds, the velocity must have been, so here at 0 second the velocity was about 25 meter per second. Then at 1 second, see somewhere here it would be like 1 second, it would be 20 meter per second. It has fallen down. At this second here you see it is about 15 meters per second. And if you go on there, you will see for every second it drops by 5 meter per second. Here also it drops by 5 meter per second. This is a retardation. Why is it a retardation? Because the velocity is decreasing. But it is a uniform retardation. Why uniform retardation? Every second the velocity drops by 5 meter per second. It drops uniformly. So if these graphs are given plainly to you, in the first case you will say velocity constant, because it's just a straight line, remains same. Velocity constant. Acceleration will be in this case 0, and we call it uniform motion. It's given here, uniform motion. In this case now we will say that the velocity keeps increasing but increases uniformly. So it's uniform acceleration. Uniform acceleration. Why uniform acceleration? The velocity does increase but uniformly. And in this case we will say it is retardation, because the velocity is decreasing, but it is uniform retardation.